Welcome viewers. Today we are going to discuss some C questions, programming C questions for JELET preparation, computer application part. The questions I have taken from the Computer Science and Technology 3rd semester 320S question paper on C. So this will help both the purpose. Those having the exam on 320S, they can view the old questions with solution, and those who are preparing for JELET, they can also get the answers to the questions with explanation. Let's come to the first question. So the question is, a C variable name cannot start with. A C variable name cannot start with an alphabet, a number, a special symbol, both B and C. So we should know that how a C variable name should be constituted. Some basic features of a naming convention of C variable. So the first one is that it may contain alphanumeric including underscore. So the name can contain any alphanumeric words or alphabets including underscore symbol. So it can start with any alphabets including underscore, but no space in the variable names is allowed. Like a variable cannot be A space B cannot be a variable, or student space name cannot be a variable. It cannot use any special symbols like hash or ampersand, percentage, etc. in variable names. It cannot start with a number. A variable name cannot be 9 underscore a. This cannot be a variable name. A underscore 9 is a perfectly okay, but 9 underscore a is not possible. Also, it cannot be a C keyword. There are 32 keywords in C. We cannot use any of them as a variable name. So probably you got the answer. A C variable name cannot start with a number. It cannot start with a number. It cannot start with a special symbol. So answer will be B and C. That is D. Both B and C is correct. Let's go to the next question. strcat strcat is defined in which of the header file? ctype.h, stdio.h, string.h and math.h. Instead of telling you right away the header file where this function is written or defined, let's see one by one all these four, so that in future if we get a different question from any of them, we can answer. So let's first see that what is there in ctype.h. So there are some of the functions that are available in ctype, like is upper. So it checks if the given string or the character is in uppercase or lowercase. So similarly, is lower for checking lowercase. Is x digit, that is to check if the digit is in hexadecimal or not. Is print, to check if the character is a printable character or non-printable character. Similarly, is alpha checks if it is an alpha, that is alphabet A to Z in large cap or small cap or not. Is digit checks if it is a digit or not. All these are defined in ctype.h header file. Now coming to stdio.h, that is standard input output, like printf, printing to console, scanf, scanning, getting output, getting input. Printf is for giving output to the console. Fprintf, this is for file, writing to a file. Fscanf, reading from a file. Fopen, opening a file. Fclose, closing a file. Putchar, getchar, all these are defined in stdio.h. Now let's see, string.h has strcat, strcmp, string compare, strlength, length of a string, strcopy, copying one string to another. So all these are in string.h. So our answer will be string.h. Let's see math.h. In math.h, these are some of the functions like power. There are two arguments, x, y. Similarly, sin x, cos x, square root, sqrt, log, ceiling, floor, all these are available in the math.h header file. So now instead of knowing only this answer, that is string.h is the answer for strcat, we know many more answers. So if the question is upper, then the answer will be C type. So we know many of them. So finally, in this case answer is string.h. Let's go to the next question. the function that is invoked is known as. So the function that is invoked, let's see an example. In this example, this is the main function and this, it is calling this sum function, though this sum function is the invoked function. So the question talking about this sum function. So the function that is invoked is known as, this sum is known as, this is known as called function, because this function is being called inside main. So as this function is called inside main, so it is also called function. So answer will be called function. Going to next question. The default storage class of global variable. So this is very important, and many questions come from this part of C, basically the storage class. So there are basically 4 storage class in C: auto, static, register and external. Among this, auto and static is very important. Auto is normally, we'll see one by one. Let's see, that will be better. Auto is for normally local variables, and it's the default storage class for local variable. Scope is within the function or within the block, that is within the curly braces. So the limited scope. And auto, we don't need actually to write the auto keyword. We normally write int x is equal to 5, so it is by default auto. If it is written inside a block or inside a function. Let's see static. So default storage class for global variable is static. It is defined outside of main and it is initialized to 0. So it is defined outside main and it is available to all the functions including main. And value remains, that is, value is not gone. In case of auto, as soon as the function, you are out of the function, the value of the variable is gone. But in case of static, it keeps the value until the program ends. So as long as the program is running, the value is there. Now register, this is a storage class is used when we write some register int x. So then we try to instruct the compiler to use the storage of CPU register for the variable, so that it can perform quick performance. It can give quick performance, but it is not guaranteed. It depends on the implementation of the compiler. So, but it says if you are marking a variable as register, it's a storage class as register. That is, you are telling that use register instead of RAM for this variable, so that the computation become fast. Normally counter kind of variables are defined as register variable. And external, this is a global variable that is visible to all the functions defined across different source files. If there are more than one C source file, in that case we have defined some variable in one of them, and we want to access that variable from all other source files. In that case, we have to mark it as external int I, something like that. In that case, we can use that I in all other source files also. So in this case, for our case, the default storage class for global variable is static, and for local variable it is auto. These are important. Mostly these are common exam. And for external, you need to remember that external is also a global variable, but that is visible to all functions if there are multiple source files. Now, so the answer is here static. Go to next question. So ampersand num means, so num num is a name of the variable, and if we put an ampersand, then what it means? Address of number, value of num, or num is a pointer, or A or B, that is address of num and value of num. So this is the answer will be, it is ampersand is known as address operator. So when we write an ampersand num, so it gives the address of the variable. So whenever we define a variable int I or int I equal to 5, so it is stored in some location of the memory, and this I points to that location, so that memory address, and 5 is the present in that memory location as a value. So let's see as an example. We have run some code in online GDB compiler, Here you see in num, then ignore this line, then address of number is %p ampersand num. So it prints this address, memory location. We can also print it using this pointer. In star p, this is an integer pointer is equal to ampersand num. So this is this, now this p points to the address of the num variable. So this time we can say this p is an integer pointer that is pointing to the variable num. So p contains the address of the variable num. So we have again printed. So when we print any address, we use %p. So address of num is equal to %p then p. So in this case we see this same address is printed. And if we print simply num, %d num, then the value of num is, that is 5, is printed. Again, if we, this star is also known as value of operator. Ampersand is address of operator and star is value of operator. So ampersand num means address of number and this p is the pointer. Now star p means value that is present in the address that is pointed by p. So p is pointing a address, the address of the variable number. Inside the num, the value is 5. So star p means it will print the value, that 5 value will be printed. So here the 5 is printed. So for this case, ampersand num is address of the number. So the concept of pointer is a little bit tricky, and I will make a separate video so that I can make it clear with more examples. Actually, more and more example you see, the concept will be clear. So, but if you copy this example and try running this one, then you will understand a few more of this pointer thing. That is star and ampersand. So ampersand is address and star is value. Let's see. So this is the definition of a pointer. For the time being, you don't need this for this question. So here address of number. Okay. Now the next question, a data structure that can store related information of different data types together. So different data types means some primitive data type, integer, character, floating point number. So if there is a data structure that has all different type of primitive data types, or maybe non-primitive data types also, that is derived data types, so then what that data structure is called? So probably you know the answer, but I will not tell the answer right now. Later I will instead discuss what is array, what is a string, what is the structure, then we will get to the answer. So let's see what is array. Array is something that stores similar kind of data types like int x10. So this is an array of integer. In this array has 10 elements, x0 to x9. So array contains similar type of elements, like it can have int x array, it could have been character ch x10, or it could have been floating point float x10. So in that case it will contain all character or all floating point number. So array contains similar data type, same data type. Now string is nothing but an array of characters, like character char name 10. So this is an array of characters that has 10 characters. So that is basically a string. Now say structure may contain all primitive data types together. Also it may contain any derived data type. Now let's see an example of a structure. So in this case answer will be structure. Let's see an code, some C code. So this is an structure is defined, structure student that has character name 50 character and integer roll number. So two different type of data type, character and integer, both are present inside a student. So this is a structure. So structure contains different data types together. So for a student we need name, roll number. We may have many other fields like student's address and many other things. So this is how now we have here written the complete program so that you can run it if you want to run. Next, go to next question. So structure member variable is generally accessed using the 4 options. So how a structure member variable, we see in the last question that the structure may have different data types and how those data types are accessed. So we first try the same question. same program, and now we need to access this name or roll number. How that is accessed? So here we have defined inside, this is outside the main. Then we have here start student, student1, student2. Now here you see that we have stored student1 dot name some Ram Kumar. Similarly student1 dot roll 19. Similarly for some values for student2. Now when we are printing, we see student1 name is percentage, then student1 dot name, student1 roll number, student1 dot roll. So this is called dot operator. So when we access the inside variables or the data types from a structure, we need to use this dot. Structure name, that is student1 dot name dot roll. In case of student2, student2 dot name dot roll. So it will print the name of the second student, roll number of the second student. So this is called dot operator. So when the member variables, these are member variable. Name and roll number are member variable of the structure student. So when these member variables are accessed, the dot operator is used in C. So dot operator is answer. So going to next question. A structure placed within another structure is known as, so this is actually known as nested structure. But we see an example. So in this case, suppose we have created a structure address which contains city character, city name and integer pin code. Then we have created a structure student, that was earlier also character name, integer roll number. Then we have added structure address add. Now this structure contains another structure variable, that is address. Now when we set the values, we have set the str copy name, then we have assigned the roll number, student1 dot roll. Now we have added let's see how we have added this city name. So we have done str copy student1 dot address dot city, then the city name. Similarly student1 dot address dot pin, then a pin code. So Salt Lake 700091. So this is how we put values to a structure which is inside another structure, that is nested structure. Then we can similarly print like student1 dot name dot roll number, then nested structure student1 dot address add dot city, student1 dot add dot pin. We can have multiple such hierarchy. We can use dot dot, how many level we can go. So this is how this is called nested structure. So in this case the answer will be nested structure. Now the next question, on 32-bit system, on a 32-bit system, an integer variable is allocated 1 byte, 2 byte, 4 byte and 8 byte. How many byte is allocated? Now here some legacy system we need to consider, that C does not define a fixed size for an integer variable, or rather any variable. What C has defined, that it has defined a minimum size, that C has defined the minimum size of an integer as 2 bytes. So earlier time when C was developed, there was mainly 16-bit CPU and very few 32-bit CPU. So 16-bit CPU, in 16-bit CPU the integer is of 2 bytes, its length is 2 byte, that is 16-bit. Now in 32-bit CPUs it can have 2 bytes, but for a 32-bit CPU making it 4 byte becomes easy for the CPU to operate. So normally the compiler designer do make it 4 bytes in for 32-bit CPU. Similarly in 64-bit CPU integer is made 8 bytes because that is easier to do operations, but they also can make integer as 2 bytes, but in that case they have to do some extra performance, 2 byte, then rest of the bytes should be null, then they have to handle that in the CPU, because in a 64-bit machine by default everything is 64-bit. So if we use 64-bit as integer, then that will be more efficient. So in general in a 64-bit CPU integer is 8 bytes, but as per definition see that 2 byte is minimum. So in case of 32-bit system commonly it is 4 bytes. Now how do we know how many bytes are used in any system? So there is an operator called size of. This function if you call, then it will return that number of bytes the data type takes. For example, here I have shown that size of character then percent %d bytes, then size of char. So character is 1 byte, you can see. Then size of integer, then you can see it is 4 bytes. Size of in the bracket int. So it will return the size of, so size of returns and some value, that is the number of bytes. So we have used percent %d. Again size of float is, we see 4 bytes. All these are for 32-bit system. The long we see this is 8 bytes. So for in case of long it is 8 bytes. So that is not here, but that is important to know because some other question may ask the size of long in a 32-bit system. So we have covered all. Going to next question, again from storage class. Which variable retains its value in between function call? Auto, static, register and extern. We know that global variable retains its value throughout different function call, and global variable, for global variable storage class is static. So answer will be static, but we will also see some example. So these are the, already we know, we have discussed different kind of storage classes, and now we see some example. Now in this example you can see that we have outside of the any function we have defined static int x equal to 10. We could have omitted this word static because global variable is by default static. Then we have written function 1, then we have printed the value of x, then we have assigned a new value x equal to 20. Then in the next function we have again printed the value of x. Now we call the function 1 first. So what will happen? Function 1 going to here, going here, so x has a value of 10, so it will print value of x as 10. So 10 is printed. Then x will be incremented to 20. Then in the next function, x is defined only outside. In the next function we have printed again x. This time x value is printed as 20, not 10. That means the value assigned in the function 1 is retained inside function 2. So global variable or static variables value retains value throughout different function call. So in function 1 this value is assigned, and inside function 2 we see this updated value. So static variables retain its value in between function calls. And the last question, a C program are converted into machine language with the help of. So C program are converted into machine language with the help of. So a C program is a high level language, and many high level language are compiled language. That is, it requires a compiler, and that compiles, that creates the binary file or binary machine language 01 file, we also call executable file, from the source code by compiling it so that it can run on similar type of systems. So in case of C program, a compiler is required. But when an interpreter is required, let's see. An interpreter interprets and executes code line by line in scripting language like Perl, Python, JavaScript, MATLAB. In this case, code is executed line by line. First one line of code is read, then it is interpreted, that is, it is basically inside, it is compiled into machine language, and then it is run on the system. So again, then the output is given, then the next line comes, and the next line is same, it is done. So in case of interpreted language, line by line code execution happens, and there is no compiler. That is, we do not get any compiled exe file. But in case of compiled languages like C or C++, like Java, we get a compiled version. That is, once we compile the program, all program, then we get some exe that we can independently run in similar type of architecture or similar kind of machine without needing any compiler. And once we compile, then we can run that exe by double clicking simply. So that is compiler language. But in case of interpreted language, we always need the interpreter whenever we want to run. We want to run a Python code, then we cannot get any exe file. We need the code and we need the Python interpreter in all the system wherever we want to run it. So in this case, for C program, it is a compiler. And another thing is there, that is called assembler, that basically convert an assembly level language code, that is the code written in the mnemonics, so this kind of mnemonics, to the machine language. It is very much architecture dependent. So different kind of assembly languages are there for different architecture depending on the mnemonics provided. So in this case we already got the answer, compiler. So see you in the next video. All these questions are complete. Thank you for watching.